Dark School presents multiplication 2. Recall that a binomial is an expression having two terms in it. Once you have understood the distributive property, you can extend it to multiply binomials. Let's do a couple of examples. Let's say we want to multiply the binomials p minus q. The two terms are p and negative q with 2p plus 3q. The idea is to think of one of these two as one single term, distribute it on the other one. Which one? It doesn't matter in multiplication. So I'm going to go ahead and assume that all of this is one single term. For your convenience, let's use a single name for p minus q. Let's say p minus q is x. Therefore, the whole thing translates to x times 2p plus 3q. The idea is to distribute this x on the 2p and the positive 3q inside the parentheses. And then of course we shouldn't forget to replace x with its actual value p minus q. Remember, we are using x for our own convenience so that we can understand the problem better. There's no x in the given problem. There's only p and q. So this is going to be x times 2p plus x times 3q. Now what's x? X is p minus q. So that needs to be multiplied with 2p plus p minus q with 3q. Now this 2p and this 3q out here, they are single terms. So this time they can be distributed on this one and on this one. Similarly on this one and on this one. Let's just do that. So we have p times 2p minus q times 2p plus, it's this plus, p times 3q minus q times 3q. Time for us to simplify. P times p is p square, therefore we have 2p square minus 2qp plus 3pq minus 3q times q, which is q square. 3q square. Now if you look at this term and this term, this is qp and this is one in pq. qp means q times p and pq means p times q. In multiplication it doesn't really matter, so they are pretty much the same. It's called the commutative property of multiplication. Therefore I'm going to go ahead and rearrange those two terms, but not before I've written this down. 2p square minus 2pq, qp is the same as pq, plus 3pq minus 3q square, which is equal to 2p square minus 2pq plus 3pq will eventually give us a single pq, positive, because 3 is more than 2. Therefore we have a plus pq. We don't need to write a 1 here because 1 times pq is the same as pq, minus 3q square. This is what you get when you multiply the binomials p minus q and 2p plus 3q. Let's do another example. Let's say we want to multiply this time x plus 1 over 2y. It's a binomial, two terms in it, times 2y squared minus 1 over x. Doing the same method, assuming all of this to be one single variable. If you want to, you can use one single name for it. This time I'm not going to do that. So I'm going to say it's all of that times 2y square, and all of that times negative 1 over x. So we have a x plus 1 over 2y times 2y square. The 2y square this time needs to be distributed on this. Remember, the boxes are for your understanding. You want to use parentheses on the actual problem, not boxes. Okay, minus 1 over x times all of that, x plus 1 over 2y. It didn't really matter if I wrote the 1 over x on this side or put a plus sign here and then times a negative 1 over x on the other side. So that's equal to this, distributing the 2y square on this and then on this, we get x times 2y square plus 1 over 2y times 2y square. Eventually some of these factors will cross off, and then distributing the 1 over x on this one and on this one, minus 1 over x times x minus 1 over x times 1 over 2y. Time for us to simplify. 2xy square. Now if you look at this and this, you'll probably realize that there's a 2 on the denominator and the 2 on the numerator you could cross off. Similarly, there's a y square on the top, which means a y times y, and there's a single y on the bottom. So if you cross off one of the two y's from the top with this y on the bottom, there's nothing left on the bottom with a single y on the top. So this is going to be a plus y. Similarly, if you cross off this x with this x, we just have a minus 1 minus 1 over, nothing crosses off in this because we just have two 1's on the top. So we are going to have a 1 over x times 2y, which is 2xy. This doesn't seem like something we can simplify further. So I would say this is the final answer.